All right, welcome back. We're going to be building on what we've been doing in this rational number integer operations unit. Today, we're going to be actually revisiting two old concepts, but then applying them to working with negative numbers. So the first thing we're going to do is revisit some old information that you will need for today's work. The first reminder is talking about like terms. So if you can remember, like terms are terms that have the same variable raised to the same exponent. So for example, if I had the term 13x and 2x, those are like terms because they have the same variable, x, and both of those x's are raised to the same exponent, which in this case is just to the first power. Another example of like terms would be 2y squared and negative 3y squared. The reason that these are like terms is that they both have the same variable, y, raised to the same exponent, to the second power. So we're going to put this in the context of, oh, actually one more thing. Like terms can also just be numbers themselves, right? So if I had like 14 and 6, those are like terms. They don't have a variable, but since they don't both have a variable, they are like terms. Now, we're going to apply that concept to simplifying expressions. So for example, take something super basic. If I had 14a minus 5a, those two terms can combine together since they both have a's, and that would simplify down to 9a. We could give a little bit of a bigger example. Let's say we had 12b plus 3x minus 4b minus 5x plus 10y. All right, so first let's identify our like terms, 12b and minus 4b. Those two things, 12 minus 4, would simplify down to 8b. My next pair of like terms would be the x's. So I've got positive 3x plus 3x and minus 5x. So reading that from left to right is 3x minus 5x, which is minus 2x. And then the 10y has no like term. So that's just going to get dropped down. There's nothing for it to combine with. So that expression right there, the blue expression, would simplify down to this expression that I wrote with black ink. So one of the things you have to remember today are what are like terms and how to combine them. There's a very brief overview. The second thing that's old news that is needed for today is a property known as the distributive property. So the distributive property works like this. If I have A times B plus C, you can rewrite that by distributing the A times everything inside of the parentheses. This is A multiplied by this whole thing. So it's A times B and A times C. So you could write that as A times B plus A times C. This and this are the same thing. One is just written a different way. So let's look at that in a number context. Let's say we had negative 3 times x plus 5. Well, that's negative 3 times everything in the parentheses. So negative 3 times x is negative 3x. And then negative 3 times 5 is negative 15. So negative 15. And the reason I'm writing that in parentheses is just to highlight the fact that it's negative and so that I don't have plus minus right next to each other. Alternatively, you could write this as 3x minus 15. That, I'll write it out so you can see it. Both of these expressions mean exactly the same thing, but remember, you can write subtraction as add the opposite, so plus negative. That would be the same way of writing the expression. Either version is correct. Let's do another example with distributive property. Let's do negative 7 times 2a minus 4. So negative 7 times 2a would be negative 7 times 2 is negative 14a. And then negative 7 times 4 is negative 28. Now, another way that you could write this expression is you could write negative 14a, that's not going to change, but you could write plus 28. The reason is when you're distributing this negative 7, since this 4 is being subtracted, another way to read this is plus negative 4. It means the same thing, but then you'd be doing negative 7 times negative 4, which is positive 28. So you would have negative 14a plus 28. It's a little bit weird, but this expression and this expression mean the same thing. It just depends on how you want to write it. But you can rewrite subtraction as adding the opposite, so plus, and then the opposite of negative 28 is positive 28. So either way, both of these expressions are correct. They both mean the same thing. That is a quick refresher on distributive property. So what are you going to be seeing today? Well, you're going to see expressions similar to this one, where the goal is to solve for x, and before you can solve, a good idea is to combine your like terms. So wherever your equal sign is, you could draw like a little imaginary line down there. On the left side of the expression, I have both of my x's on the same side. So why not combine those together just to shorten things up a little bit? So 8x minus 6x, those can combine because they're like terms down to 2x. And now the expression at least looks a little bit nicer to solve. Remember, we're doing reverse order of operations. So I'm first going to look for any addition or subtraction that I can undo, that I can inverse. So I'm going to do the inverse of minus 25 is plus 25. Inverse operations cancel out, and whatever you do to one side, you do to the other. So now I've got negative 35 plus 25, which is negative 10. That's what's on the right side of the equation. And on the left side, I am left over with just 2x. And since that's 2 times x, I'm going to divide by 2. And I'm going to divide by 2 on this side. And what's left over on the left-hand side is just x, which is what I want. I want x equals, and negative 10 divided by 2, a negative divided by a positive is just a negative 5. And that would be the solution to this equation. That's what we're going to be doing today. So in this example, I had to combine like terms as a first step. Let's look at another example. I bet you can guess what we're going to be doing in this example. That's right, we're going to be using some distributive property. So I see distributive property as a first step right here, right? 2 times 1 and 2 times that 5x there. Notice the 2 is not being multiplied by the 4 as well. It's only being multiplied by the things that are in the parentheses. This plus 4 is on its own. It's not getting distributed to. So that would be 2 times 1 is 2. 2 times 5 is 10. And plus 4. All right. Now we can solve. All right, so the first thing I'm actually going to do is I'm going to do 2 plus 4, because those are like terms. They're both whole numbers with no variables. So I'm going to do 2 plus 4 and make that 6. And now I can solve a little bit easier. How do you get rid of positive 6? Well, I need to subtract 6. 6 minus 6 is 0. That gets rid of that there. Whatever you do to the left, you do to the right. Negative 8 minus 6, I'll write that over here, is the same as negative 8, add the opposite. So add negative 6. So it's negative 8 plus negative 6 is negative 14. So I've got minus 10x is equal to minus 14. And then my last step here is, if this is negative 10 times x, I'm going to divide by negative 10. And I'm going to divide by negative 10 over here. And so I'm left with x is equal to, negative divided by a negative is a positive, and 14 divided by 10 is 1 and 4/10. So my final solution to this problem should be x is equal to positive 1 4/10. All right, so your work today is based on IXL. You have two assignments on IXL. They are both found in the 7th grade section. One is C.20 and the other is S.9. Take your time on them. You're going to want paper and pencil to work on the side. Remember, the goal is to not be doing this with a calculator. We're not there. We can't see what you're doing, but we trust that you're trying to do what's best for you. Eat your veggies, as they say, even though you don't like to. It's good for you. So don't use a calculator. Get some paper, pencil, good old-fashioned, do your work, show your work, and take your time with it. Additionally, if you open up the notes, the hard copy of the notes that are attached to today's assignment, there are 8 additional extra practice problems. If you're looking for a bit of extra work or a bit of an extra challenge or just want to really make sure that you're doing well with this, please take the time to look at those. Some of you are whizzing through this and are looking for a little bit extra. Here it is. Here's 8 extra problems for you to do. You might not want to do them today. Maybe you spread them out and do them tomorrow or later in the week. But I would take a look at those and try your best. We'll post answers eventually for them, but try. See how you do on your own. Anyways, enjoy math today. Do your best. Later.